Yeah, so let's just get right into it then. So the first question I have is write a function that checks if a given string is a palindrome, which would mean it is if you spell it backwards, it creates the same input string. Like so, a good example of that is race car, because race
Right.
car spelled backwards is race car.
Right. So
Yeah,
is it all right if I code in Python? That's just my preferred.
yeah, that's fine.
Um, all right. So let's see. Um, so first thing that occurs to me, obviously, I'm going to need to put it into, well, I'll need to have an input, but for now, I'll just hard code it. And I'm basically just going to need a for loop that analyzes each character, that compares 0 to -1, 1 to -2, et cetera, et cetera. But then the tricky part, I think, is going to be making it so that it can take a number of different lengths of string. And it would be a little different depending on whether there is an odd or even number of letters in the string. So I think the first thing that I would do is I would check to see if the string is even or odd with modulus. Basically, palindrome modulus 2 equals 0. And then if it's not, then I'm going to run something else. But then, let's see. So if it's an even number of letters, you're still going to need to check its length. Where so I think we could just do for palindrome dot length over 2. I don't know if my syntax is right now. Sorry, I've got a bad keyboard.
No worries. Yeah, you're saying like loop over each. I mean, are you trying to loop over each letter in there, or are you trying to loop over the numbers from 0 to the length, or length over 2?
Yeah, that's true. Oh god, this is not JavaScript. Yeah. Right. Let's see, how would I do that? So, I mean, there are a couple ways that I could do it. So I'm setting the global variable there. I think what I would, I think I would want to do it as for I in palindrome dot length. Or no, it's in Python, it's len palindrome, I think.
Yeah. Like for I in range length palindrome?
Oh yeah, range.
Okay, so you're gonna loop over the numbers from 0 to, whatever the length is.
Yeah, so I would start there, and then I would want to say if palindrome I equals let's see, it would be if it equals palindrome it would be -1 times I plus 1, right? Because we're looking at palindrome 0 and palindrome -1, and 0 plus 1 times -1 is -1 palindrome. So 1, 1 plus 1 is 2, -2. Okay, so if that's the case, basically we want to return true. This is Python. But we don't need to just return true. We need to return true the whole thing. But really, we don't need to return true. We just need to really, okay, so really we only need to check if it doesn't equal that, because if at any point it doesn't equal that, then we need to break. I can't remember whether break works for loops in Python, but I'm just going to say break for now, and I can debug it later if it doesn't.
I think it will,
yeah. I know I know it works for while loops, but anyway, so for each of those, if at any of that point it doesn't, then break out of the for loop. And then I'm going to set a variable here is palindrome. Oops. True. Is palindrome equals false. So if at any point it does not equal the if at any point this is untrue, then is palindrome equals false. So then if it makes it all the way through there, then it should, and then I can just say if is palindrome equals true. Oops. Print. It's a palindrome. This is false. Print not a palindrome. And I'm realizing as I type that I don't think I need this first if statement, because if there are an odd number of characters, then I think the middle character will just compare itself to itself. So that should work just fine.
Okay.
I imagine that there is some debugging that I need to do, but I think that this should work. Where am I going to put this? 1 second. Right. Node syntax. Oops. There we go. Load cannot be interpreted. Oh, okay. 5. Oh, I see. I need to round it. Should be ceiling. Is that not how you do that?
I don't remember off the top of my head how to do that in Python.
Yeah, hold on. I'm just going to search it real quick. Yeah, it's ceiling. Seal.
You have to import it?
I might have to, yeah. Yeah, import math.
Okay.
Yeah. Oh, I don't have to do that.
Right.
Okay, race car is a palindrome. That works. Floors. Okay, so we got it working.
Cool. Do you want to double check those edge cases though? You were saying like odd number versus even number of characters. Let's
Oh
just
yeah,
make
totally.
sure.
Um,
So what is race car? Is that even?
RACE.
It's odd.
That's odd, so it looks like it worked.
Yeah, so let's try an even number then.
Yeah.
What's a palindrome? It's even.
Noon.
Yeah, that's a good one.
Noon is a palindrome.
Okay, cool. All right, this is good. The only thing is, I originally said, can we make a function that does this? So let's just put it in a function.
Yeah.
That returns true or false. It doesn't need to print anything.
Checker.
Okay. Yeah, this looks good.
Yeah.
And then do you want to test this function out really quick?
Sure. But let's see. All right. Input
Yeah, that'd be good. Just print it out.
Yeah.
Nice. Okay, yeah, it looks good.
Yeah, cool.
All right, I'm happy with this. Okay, so this was the warm up, and now we will do a question from the book.
Cool.
And the book had a question that had to do with palindromes, so I thought it might be good to kind of warm up with, doing something that made us all familiar with what palindromes are and all that. So the problem is palindrome permutation, which is problem 1.4. If anybody has the book and they want to refer to this later, it's chapter 1, problem 4, I think. So the problem is given a string, write a function to check if that string is a permutation of a palindrome, meaning if you could rearrange that string in some way to create a palindrome, then your function should return true. And if any rearrangement of that string, you can't get a palindrome out of it, then your function should return false. So palindrome permutation. So an example that they give in the book is the let's see, is this an example of a palindrome or not? They give an example of the input TACT, tact space COA, COA, and one of the permutations of that is taco cat, which is a palindrome. Or taco, yeah, taco cat is a palindrome. So tact COA is a permutation of a palindrome.
What
So
page
it's
are you
kind
on?
well, I'm looking at the solution page, which you probably don't want to jump to that. Do you have this? Do you have edition 6 of the book?
Let me see. Yeah, 6.
All right. Well, the solution. Oh, you're not. Oh, sorry, you're not Griffin. The solution is on 195. If you want to look at that. But yeah. So let's write out the example in somewhere so we can refer to it. Like we'll pass in tact COA and we'll see that it should return true, and then we'll think of an example of something that should return false. So the function should be called something like palindrome permutation, or is palindrome permutation.
Yeah.
Let's just, for the sake of seeing it up on the screen, let's like write out the some examples of calling it in like comments. You can make a comment and we'll write it out. That way everybody can see.
Just the description of the task.
Yeah, like what the input and output could be. So if you input tact COA, TACT space COA, that should yeah. Well, taco cat is one of the permutations of tact COA.
Yeah, that's just the first variable name that entered my head. Yeah, that's right. So basically what I need to do is check to see whether there is an even number of at least all but one of the characters in the given string. So I want to sort that string. I'm not sure whether sort in Python can be used on strings. I think it's only for integers. And so I think I'll have to.
Can you explain more why you want to sort?
Basically, I don't know that I even necessarily need to. My thinking, was to have each of the letters next to each other, but I don't know that that's necessary to check for whether there's an even number of them in the list. So,
well, like let's say let's say you could get what you want in any way, whether sorting or not sorting. What you're saying, you at the end of the day, you're saying you want the counts for each character,
yeah,
and then you'll check those counts, and you're saying all of them should be even, except one of them could be
right,
odd.
right.
Okay, and then you're saying sorting could be one way of getting the counts, because then you could each similar letter would be next to each other, so it'd be easier to count them.
Potentially, but I don't think that's actually necessary. I could do a for loop. That's kind of a brute force solution, but
It's fine. Like for right now, let's not worry about efficiency. So what is the brute force solution you were thinking of?
I think the brute force solution would simply be to do a for loop for each letter in the string. You'd go through the entire string and count the number of matches, basically. Yeah,
Sure.
Yeah. Let's see. For I in string. Let's see. I need to do nested. Yeah, I do a nested for loop for J in string. Let's see. Match count 0, 0. If equals J, match count plus equals 1. Plus equals 1. So hypothetically, that should yeah. So and then we call that odds equals 0. And then this level, if odds modulus 2 equals 1, nope. If match count 2 equals 1, odds plus equals 1.
Okay, I see.
So hypothetically, it should get to the end of that, and then once it's done there, I can just say if odds is less than or equal to 1, return true. So let's see. Print, yeah. Okay, so it returned true there. Let's give it something where it definitely isn't. Okay. GGH. Oh, wait. Oh, no, yeah. Okay, cool. None. Oh. Else. Else. And false. False. Okay, so far it's working.
Yeah, no, that looks good.
I think I could test edge cases here. Just put some more in. Look at an actual palindrome. True.
Maybe just add like one thing on the end of that, and then it won't work anymore. False.
False. Yeah.
All right, cool. This is pretty good. One thing that I thought was going to be a bug, but maybe it's not, but maybe you can help me understand it. I thought that for I in A string and for J in A string, on the first, iteration of the inner loop, wouldn't I and J be the same every time?
Yes, they would. Well, yeah, on the first they would, but I think that's okay because it should be counting itself in order to because we want all that really matters is that the complete count of that number is even, and so it needs to count itself in that tally.
Yeah, well, I guess I just thought there would somehow be like a double counting going on, like consider when the first loop, gets to the second letter, then the second loop, when it gets to the second letter, you're counting it there, but you're also, or wait, maybe that's not double counting. Yeah, I don't know. It appears to be working, so
cool.
I think I'm good. We don't need to go down my rabbit hole of misunderstanding. So no, great. That's awesome. So I have, I don't know if we have time, but I did have one more problem prepared.
We're about at 30 minutes, but just giving you a heads up.
Yeah, well, then maybe we should use the rest of the time for feedback and other questions then. If that's cool with you guys.
I mean, these ones are kind of easy ones. I could go for a challenge.
You want a harder one? All right. Well, sure. Let's see how far we can get with the harder one. So the next question, this one's not really about palindromes anymore, but it's about strings still. It's still about permutations. Generate all permutations of a string. So
okay.
So like the tact koa, you would get taco cat, but you'd also get all the other ones too. So maybe return an array of, all the different permutations.
Yeah. You could do a bubble sort. That would be the most inefficient way of doing this. No, okay, so yeah, that one's kind of more of a challenge.
And maybe let's start with writing out what the input and output would look like, just so we're all clear on what that's going to be.
Sure.
Maybe just in a comment, you could write, if you pretended to call it in a comment, and then you could show what the output should look like.
Okay, so out all possible permutations.
Well, what I actually want is a function that returns an array that contains all permutations.
Okay. Returns an array that includes all possible permutations of a string.
So in that comment block, what I'd like to see is if we, like an example invocation, so like write out what it would look like to call the function, and then write out the array that it would return.
I think to do this would be, you'd start with all the permutations that start with C. So it would be CAR, CRA. And then you would want to do ACR, and then ARC, and then RAC, RCA.
Yeah, exactly. Yeah, this is basically what I was picturing, something like that.
So okay, first step, how would it know at the end that's gotten all of them?
I don't know if you need to think about that right away. I think maybe if you got the logic right for generating those combos, it kind of naturally would produce all of them, and you don't really have to like check if you produced all of them.
Right. So I think that you'd want to check all of the indices. So you could generate something that checks for every permute, because really that's all you really need is 0, 1, 2, 0, 2, 1, 0, or 1, 0, 2, 1, 2, 0, etc., etc. So you could do a for loop. The question is, how do you dynamically switch those around? do something similar to the first one.
So right now you're thinking about how would you swap the letters around?
Yeah, well, I'm trying to think about how I would, yeah, but really I would swap it around by index, because the trouble is in my mind is like, how do you do that for any length of string?
Well, maybe we could start off by hard coding, a length of 3, let's say, for this string here.
Sure.
And then that might give clues into how to do it for any length.
Well, okay, so this is gonna, so that's gonna return 3. And we basically need 3 times 2. That's not always gonna be the case. It's gonna be, well, anyway. I'm not sure. I really need to think about this. Okay, the question in my mind is, do I need to apply some kind of sort method, or do I just need to do, is there some simpler algorithm that I can apply?
What would the sort thing be that you're referring to?
Yeah, well, I was thinking like a binary sort or a merge sort or something like that, but that wouldn't really work because that only is going to arrange it by you know.
Right. That puts it in sorted order, but you want
sort of, yeah,
a bunch of different orders.
Yeah, I want every possible permutation. So it could loop through. Because if it starts at index 0, it'll then look at index 1 and index 2. No.
I mean, how did you do it in your head? When you did it on line 4.
Right.
What was the algorithm that you used?
Yeah. Well, so for me, that's just you start with the first one, the first letter. I mean, it's 0, 1, 2, 0, 2, 1, and then you swap them. But I'm not sure how to do that in computer speak.
Well, let's detail that out a little more. So you start with the first letter.
Yeah.
So let's say you write the letter C. Okay, so
Yeah.
you write the letter C, and then how did you know the next letter would be A? Like, or just go really detailed. Like, what did you actually do in your mind, letter by letter?
Right.
Like, how'd you do that?
Well, so that's just the order that it's in.
Okay, so yeah, that's fine. So okay, let's say you started off with the order that it's in, but then how'd you do the next one? CRA.
I started from the first index, and then I skipped over the second index and went to the third index, and then I just kept going from there. And because the idea is that you would always
and then once you had done the C ones, you kind of moved over where A is now the first letter.
Yeah.
And then once you did all the A ones, you kind of moved over. Now R is the first letter.
Yeah. So then it really.
So you kind of looped through C, A, R for those starting letters. But then you also kind of had an inner loop too, in a way, because like, let's say when we did ACR and then we did ARC. So it's kind of like you had this loop, and maybe one loop was kind of going from C, A, R, the outer letters. And then for each one of those, though, you had an inner loop that, decided what the second letter would be.
Right. So I could do nested loops, but it would need to dynamically create a number of nested loops equal to the number of characters in the string.
Yeah, well, but I did say we could start maybe by just doing the hard-coded thing. Like, let's say there's 3. And then once we get that working, I think we'll maybe understand the nature of the problem better. And then we could talk about how to potentially make it dynamic to the length. But let's just, as an easier problem, let's just see if we can do all permutations of a fixed length. Let's say 3.
I think that this is something that I can do with nobody watching me, but I don't know that it's something I can do with a bunch of people watching me.
Yeah, I understand. Well, I don't know what our time is like. Do we want to move into questions and feedback and other things?
Yeah, we've got a little less than 15 minutes, so that would be great, actually.
Yeah,
Sorry
okay,
to
let's
cut
do
you
that.
off.
Oh, yeah.
This is kind of the extra credit question here, so this is the one I didn't think we would finish.
Okay.
So that right on schedule in that aspect, or according to plan, I should say. Okay, well, let me give a little feedback. So the main thing that I noticed was sometimes you didn't really explain what you were thinking, and sometimes I could figure it out, so then it was fine. But I think you would kind of say what you're about to do, but you didn't explain like why or like how it would help. And then sometimes I could piece the dots together in my head and be like, oh, okay, I see why he's doing that now. But I didn't always know exactly why. And then towards the second half of the interview, at some point, I just started asking more questions. So I would just kind of ask you what you're thinking. And like, I would just ask, okay, wait, so what do you mean by that? Or why are you doing that? But at first, when I was kind of just sitting back, being more quiet, and I didn't ask that, and you just didn't say it. And then, so I didn't really know until I would piece it together myself. So always just be a little bit more like, vocal and explaining like why you're doing things. And one of the reasons for that too is because if you say something that's like going to send you down like a bad path, like you're going to just get to a dead end, it's going to waste a lot of time. Sometimes the interviewer will stop you from doing that. But if you don't explain why you're about to do something, they might not stop you because they don't want to presume why you're doing it maybe. So maybe, you know, so they'll just kind of let you go and do it. And then when it becomes clear that it's down a bad path, maybe you've already wasted some time, and then maybe it can be corrected, but you've already wasted time. So if you just say up front, like, here's my plan, here's what, you know, I think I should do, here's like why I think that, how does that sound? And then the interviewer can be like, yeah, that makes sense to me. Go ahead and go forward and do that. Or they might be like, maybe let's do it a different way. But if you don't give them that, then it's like, who knows if they're gonna like stop you and do that for you, or if they're just gonna let you go and you might go down a bad path. So it's super useful to ask those kinds of questions, or like it prompt them like, does that sound like a good plan? And the interviewer can like give you feedback. Because if you ask them, a lot of times they'll say, you know, but also in general, I think it's just something people are looking for too. Like, does the interviewee communicate a lot as they're coding and explain their process, and is it easy to understand like what they're thinking? I think that's just a general thing that they're looking for. But my other point was that it would actually help you as well, because they might interact with you and help you more. So that would be probably my main tip. I think that was really the only thing. Well, okay. I mean, I guess I could say that at the first half, you were like mixing up JavaScript syntax a lot with your Python, which isn't really something I would mind that much personally, but I know some interviewers would knock you for that. They would, you know, they would see that as like a minus point, but I didn't really care because I know that people mix up languages when they, and I know that here at CodeGuild we use Python and JavaScript, and they're similar languages, and we just get them confused. But it could look like, especially if the interviewer didn't know JavaScript, let's say, and it was like a Python job, they might just think that you don't know Python very well and that you're messing up. But because I know JavaScript, so when you said .length, like I'm like, oh, he's just doing JavaScript in his head right now, or he's just mixing that up. So I don't know. It's one of those things where that could be a point against you as well. So maybe just, and I know you didn't have a lot of time to practice for this, but if you ever, for advice for everybody else, if you're, you know, going into a technical interview, make sure to really practice the language that you're planning on using for the interview. Make sure to practice these kinds of problems with that language. So then you're just less likely to make little syntax mistakes that, you know, you don't want to have something so trivial be something that is held against you. So it's because it's low hanging fruit to correct that kind of thing. So just practice that stuff. But I don't, like I said, I don't really knock Griffin for that, but I just thought I'd point that out. The main thing was the communication thing. Just, you know, ask the interviewer, like, explain your plan, and then ask them, does that sound like a good plan? And then the interviewer can say yes or no. And the interviewer can decide how much they want to engage in that process. But I've found personally that usually it works pretty well. And usually interviewers will like engage with you if you ask them things, and it can like really help you to solve the problem. So in the like I said, again, in the second half, it might have felt like that was happening, but that's because I was the one asking you, why are you doing this? So in the first half, when I wasn't doing that, it felt a lot different. So you could be the one making that process happen though. And then you don't have to rely on your interviewer to do that. Otherwise though, good job, dude. And props for solving that palindrome permutation problem. It was kind of like the trick of it was to realize that you could count the letters, and if they're even numbers except for one, that was kind of like the trick of it. And you seem to see that like extremely quickly, so you kind of were able to jump straight to the solution. So good job on that. And overall, you know, you solved the problems that I gave you, so you know, you can give yourself a pat on the back for solving the problems. But otherwise, yeah, I think that's all I have. Did anybody else maybe notice something? Because as the interviewer, I was also kind of in it, you know, anybody as an outsider looking in, do you have some, did anybody notice something or have some feedback they want to provide?
I thought you were spot on, especially with the, because I feel like what they're looking for is they want to hear where your brain is going more than the coding or anything. They're going to want to, and it is, I mean, I feel like I narrate my thoughts most of the time, even when I'm not in an interview. So easier and, you know, more instinctual for some people than others. But yeah, that would be the only thing I could think of was just, you know, let your mind kind of, or your mouth
Yeah,
rather.
Yeah, and that's something you can practice. Like if you just talk out loud as you're practicing these problems by yourself, and then obviously these mock interview events would obviously be a great place to practice that. So like next week for you guys. Yeah, but you can get better at that skill for sure. It's not just like people who are doing that anyway are good at it, and everybody else is going to be not good at it. They have an advantage, but you can totally practice it. It's not actually that hard once you practice a few times with a friend. I used to do these with my buddy when I was in college. We would give each other mock interviews, these kind of problems, and we would just talk out loud as we're doing them. And once you do it a few times, it's not that bad. It's pretty easy. So yeah, but thanks, Nick, for the feedback and all that. Anybody have anything else? Cool. Griffin, do you have any thoughts?
I don't like an audience when I'm coding.
Yeah,
That's what I've discovered.
Yeah, that makes it harder. I agree 100%.
Yeah,
luckily when you're doing it with like a real company and stuff, usually it's not like recorded, and there's not like several people. Usually it's just like a few, and it feels slightly more conversational sometimes too. This maybe feels more like an audience than it would. But yeah, just talking out loud in front of people as someone watches you is another thing that you kind of have to practice. And once you practice it, it's it's a skill that you get better at.
So I mean, I actually have a fair amount of public speaking experience, but the tricky part for me is letting people in on my thinking process while it's still happening, because I jump around a lot in my brain. And so letting someone see that is very uncomfortable.
Yeah.
I much prefer to like compose myself, figure out exactly what I'm going to say, and then go for it, which I can do fairly easily. But when I'm still figuring things out, no, people don't get to see that. That's not cool.
Well, you could still kind of maybe work on that though. Like you were saying, you would be okay with thinking through what you want to say, kind of planning it out, and then saying it. That's fine. I'm not saying don't do that. What was happening though was you weren't saying what you're about to do, and you would just start coding. So you don't have to necessarily just straight up think out loud where you're just saying every single thought that comes to your head. You could take a second, plan out what you're going to say, and then say it. But what was happening instead was you would just kind of start writing code, and I didn't actually know what you were doing until I would piece the parts together. I'd be like, oh, I see why he's writing that line of code, because it ties back into this or whatever. But you could just be saying that, like, okay, I'm gonna, I'm trying to think of some of the code that we wrote today. Like I'm gonna loop over this array because of this, because that will help with this other thing. Does that sound like a good plan? But you would kind of just be starting to write the code, and then you'd kind of be saying it out loud, like sometimes. But then I didn't even necessarily know. Like I said, in the second half, I just started asking you. So I'd be like, why did you say something about sorting? And you'd be like, well, I was thinking if I sorted it, it would be easier to check, the how many of each letter there are. But like before I asked you, if I just wouldn't have asked anything, who knows how much you would have coded before you would have explained why you were thinking about sorting it. You know what I mean? So I'm not saying you have to say every word out loud that you're thinking in your mind, but just like establishing what the plan is before you start coding, and then kind of checking in every now and then with the interviewer of like, okay, I'm about to code this idea. Does that sound like a good path to go down? Basically, that's all I was kind of talking about.
So I just had a question for June, because I want to sign up for this, but I'm not going to be available during the day. This is kind of my last day that I'm going to be available during the day, but I'm in the night class.
Absolutely. If you're unable to do a mock technical interview during the day, Daniel, what is your last name? I can connect with you separately, and we can schedule
That's
a mock.
REYES.
Oh, that's right. I'm sorry. I've got it. I'll get in touch with you.
Thank you.
Cool.
I have
Well,
one last, go ahead, Evan.
I just want to say, like, I want to end on the note of overall, like, yeah, I was impressed that you solved those problems so easily. Like, good job, dude.
That's great. And Evan, can you give, just for all of us on the screen here, just to kind of a reality check coming out of the boot camps, you know, and going through a first mock technical interview, just kind of, you know, how much we need to know, what to expect, those kind of things.
Yeah, well, one thing that's really hard to get right is like, what kind of questions do interviewers actually ask, because every company is different, and especially the bigger companies that are popular for like trying to get into, like, basically the kinds of companies that like this book is kind of like targeting to help you land jobs at, like the FANG companies. These kind of questions are kind of like harder, I guess, than if you haven't learned data structures and algorithms. They're kind of harder if you're just coming out of the boot camp, because you haven't seen some of the things in this book. Like, you probably haven't seen linked lists. You haven't really worked with trees very much. Some of those problems are going to be pretty hard. But a lot of companies don't even ask those questions. It's really hard to say, like, if you're doing like your first interview at a company, like what they're going to ask you and like what you should prepare for. Because some companies just have you, maybe it's like a front end job, and they just have like a little project. Maybe it's like a little to-do list or something. And maybe there's like a little feature they want you to add to the to-do list. And then now you're doing something that's a lot more realistic for your day-to-day coding. But if they ask you one of these more tricky, puzzly questions from these kind of books, which is pretty common, so it's good to prepare for. That's the kind of thing, though, that you have to like practice specifically for. So it just takes time. And if someone hasn't practiced these kind of questions, I just in general wouldn't expect them to do very well on their first try. But it's something you have to practice. When I went to a boot camp a long time ago called Hack Reactor, we practiced these problems, and like, the first couple days I wasn't able to solve any of them. And we had a thing when we were preparing for jobs where we would kind of do these every day. And after a while, though, and it was like most students weren't able to do them, and then after a while we started being able to get more of them. And then at some point we would get most of them. And I think it just takes a few months of drilling these problems, to be honest. And there's just no way around doing that work. Unfortunately, in the Python bootcamp, we haven't learned enough skills and have enough experience to even start practicing these problems until maybe later in the bootcamp. So we don't really have a few months to just drill these problems, because on day one, it wouldn't make sense to ask someone to do one of these. That's why it's kind of difficult, because it's kind of up to you guys to be drilling them on your own when you're doing your job search. Sorry, I don't know where I am anymore. I'm just talking. I forgot what the original question was. Yeah, I think it's okay to feel like these problems are really hard, and you need a lot of practice especially when you first open cracking the coding interview, because the book was kind of written for college grads who have already taken data structures classes. So you're not supposed to be like learning these data structures from scratch when you're reading this book. You're kind of supposed to already know what they were, but you just haven't necessarily practiced these kind of questions so much. That's kind of the audience of this book originally. But now we have all these bootcamp grads who are also trying to get jobs. It's not just for college grads anymore. But the industry is still asking these data structures questions in a lot of cases. So it is something to practice. So it's going to be a little harder for you guys at first to learn how to do these, but it's something to just be okay with, that it's going to be hard, and just keep practicing. And then, if you drill enough of them, you'll start to realize that there's a lot of common patterns. So similar problems will come up, and you'll be like, oh, I've solved one like this before. Like the permutations one, we were doing, the anagrams of a string is technically what we were doing at the end there. But you might get asked a different question, like, if you have a set of numbers, give me all the combinations you could arrange those numbers. And that's basically the same as all anagrams of a string. It's just worded differently. But if you've done one of them, you kind of know how to do the other one. And it's that kind of thing comes up a lot where, you know, even though the book has like hundreds of questions, there's really only like 20 different types, I would say. And once you've done, you know, enough problems, you can identify those similarities. So that makes it easier too once you start identifying those patterns. I don't know, anything else on that, June? I forgot what the question was.
No, that's great. So
Cool.
I'm gonna stop the recording. I want to thank you, Griffin. Did he get the job, Evan?
Yeah, sure. I would say, you know, one thing that to keep in mind too about this is in isolation, it doesn't always make a lot of sense how to judge someone. It's really the relative performance of all your candidates. And I don't think it's necessarily like companies have a specific bar where it's like, if they solve, I have 3 questions in mind, and if they solve 2 of them, then they make it. It'd be more like I would have interviewed 5 people, and whoever I liked the most would be the one who would get the job. That's how it works in the real world, to be honest. So, you know, I don't want to mislead people by saying, oh yeah, if you perform this good, then it's, you know, you'll get the job, because it's way more nuanced and tricky than that. I've even had times where I asked the interviewer, I said, why didn't I get the job? I thought I did so well. And the hiring manager said, oh yeah, your feedback was extremely positive, but we just had so many really qualified applicants. We had other people that we wanted as well, but we'll keep you in mind in the future. So like, you know, I got good feedback from my interviewers, but they just had people they wanted even more. So, you know, that's, I always want to like mention that, because I think people get discouraged sometimes when maybe they do good in an interview, but they still don't get the job for some reason. So I always want to point out, like, it's not just about how well you do. There's a lot of other factors, like who else did they interview, and, you know, what other advantages did those people have, you know, going for them as well. So it's all very nuanced. But like I said, I was impressed with Griffin's ability to solve those problems quickly, especially the second one. When I was reading it, it took me a long time to figure out that trick, and Griffin seemed to think of it like immediately. So that was cool. So he's a good problem solver, a good coder. So, you know, I'll give him respect for that.
Well, thank you, Evan. Thank you so much, Griffin. Thank you so much, Evan, for sharing all of your knowledge and your information.